Hey guys, today we're going to tackle question number 35, search insert position using Rust. So to get started, we can give question a read. So it says, given a sorted array of distinct integers and a target value, return the index if the target is found. Okay, if not, return the index where it would be if it were inserted in order. Okay, that makes sense. And now it says you must write an algorithm with O log n runtime complexity. So when I see this, so two signs. First is it's a sorted array. Second, it must be done in log n. This tells me that we probably have to use a binary search, which we will go over in a bit. So let's look at the examples. It says nums 1, 3, 5, 6. Target is equal to 5. So in this case, it should return 0, 1, and 2. 2 here, it should be inserted before 1 and 3, therefore it's saying 1. Okay, fair enough. So the easiest solution, of course, it's not going to be log n, but you could do it in linear time, which is simply just going over iterating through the loop. So, you can say, hey, if the target is, until the target is less than or equal to less than, as long as the target is less than the number you're comparing it with, keep iterating. As soon as you find a number that is greater than or equal to, return the index. So for example, this one, you're going to see 1. Since it's less than 2, you're going to move to the next one, and you're going to find that 3 is greater than or equal to 2. In that case, you're going to return the index of 3, which is just 1. Of course, that's O of n time when we need this to be done in log n, and that tells us that we're probably going to have to use a binary search because binary search takes log n and also the array is sorted. So there's two ways you can do binary search. One is you can just iterate through it. Other is you can do it recursively. For Rust, it's much better if you do it the iterating way, because recursion gets a little complicated with the Rust's ownership and all. So to do it the other way, we can first see how this is going to work. So we'll just write 3, 5, 6, and we're going to be searching target is equal to 5. So now we're going to have 2 pointers. So we're going to point left, and we're also going to point it right, which is going to be the length. So 1, 2, 3, 4. And of course, we don't want it outside, so we're going to say length subtracted by 1. And then what we're going to do is we're going to find the middle of these two. So the middle of these two, it's going to be, and we're also going to floor it right after. So if we say length subtract 1, so 1, 2, 3, 4, 3, 3 divided by 2 is 1.5. And if you want to floor it, it should be 1. So then we're pointing at 3, and we're going to say, hey, look, if this is less than the target, that means our answer should be on the right hand side. So if the mid is less, then we're going to move our left pointer to where the mid is at. And I'm pointing at mid will be left will be 3 and right will still be 6. Now, since we already compared 3, we can just say left every time we find it will be mid plus 1. In that case, we don't look at 3 again. But so there's that. So now so if I just copy this over, so our left now will be 0, 1, and 2, because this division gave us 1.5. Flooring will give us 1, and then we added 1 to move to the right. So now we have left is equal to 2 and right is still the same. Now length subtracted by 1, I'll just replace this with 3. And then we can find the mid of these two. So to find the mid of this two, we can just do 3 plus by 2 divided by 2. So in that case, left plus right, so that's 5 divided by 2, that's 2.5. Once again, you want to floor it. So left will once again be 2 and right will be 3. And this time, we're going to see, target does equal, so we're just going to return that. All right, in the case where it does not, we want to return where left is, because left will be pointing at where the next number should be. So then if you want to do it, what do we need to do? First, left and right, we need those two. So we're going to say mute, left. It will be I32. Oh, I32, which is going to be equal to 0. And we're going to define right as I32 again. And this time we're going to say len subtracted by 1. So nums len subtracted by 1. Okay. Oh, and then when we get this, actually, it's going to return a usize. So we're going to need to cast this to I32 and then subtract it by 1. Just rush things. And then we'll go through the loop again. So remember we said we want to do it until left is less than or equal to right, because when this crosses over, or when these two are equal, you know that either that's like, you know, that's where the number should be, or if it's over, that's where the number should be. Essentially, you don't want to keep doing it. You want to stop there. So left, so while say left is less than or equal to right, let middle. So middle, so how do you find middle? Middle is going to be right added by left divided by 2, right? And we just want to put this, we're going to cast this to F64 in case it overflows, and then we're going to floor this. So we can do this and then floor. And then once we're at floor, we want to cast this down. So we're just going to cast it to as I32. Yeah, oh, let's do this as. So left and right divided by 2 is gonna, we're gonna cast it as F64, and then we're gonna floor this, and then we're gonna cast it down to I32. Now what we want to do is we want to say, now we want to compare, we want to get the number that's at the middle, right? So we want to get the number that's at the middle and compare it with our target. If it's equal, then we go ahead. If it's less than a target, then we know it's going to be in the left stack. And if it's more than the middle, then it's going to be in the right stack. So we're going to say if let sum current is equal to nums.get middle as usize. So we're going to say nums.get, and that's going to return either sum or none. So we're going to say, look, if there is something, then we want to go further. Otherwise, just keep iterating. It's probably never going to happen, but just in case. So we're going to say get middle as usize. Once again, middle is I32, and we need when we want to index, we need it to be usize. So we need to cast it. So once we're there, we're going to go ahead and say current equal. So we need to dereference. So we'll say current. If current is equal to target, well, that means we found the target. So we can just go ahead and return middle, right? Because that's where it's located. And current is the index at middle, or sorry, current is the number that's stored at middle. And we need to return the index, right? So it'll be middle. Now we're going to say, look, if current is greater than target, what does that mean? If the current is greater than target, then that means it will be in the left-hand stack. So we need to move our right down. So right will be equal to middle subtracted by 1, because it will be in the left of middle, from left of middle to from left to the left of middle, right? So right will be middle subtract 1. Similar things apply. Similar thing applies to our left hand side. So if current is less than, then in that case our right should be middle added by 1. And then we're going to keep doing this, keep doing this, keep doing this until left is less than or equal to right. When left is greater than right, it means that that's where the number should be. So we're gonna say return left. And then we're just gonna go ahead and return left. And then we're gonna see if we get any errors. So we're gonna run it. Okay, I should have just submitted. Okay, let's submit it and see what the result we get. Okay, perfect. Okay, so I'm gonna go over the algorithm with you once again. So we're gonna have the left and the right. Then we're gonna say until left is greater than, less than or equal to right. We're gonna keep iterating and we're gonna find it. If we find that the number is less than the middle, then it's gonna be in the left stack. Therefore, we need to move the right to the middle, subtract 1, and then vice versa for left. If it equals, then it's just simple case of returning middle. Now, why is it, and then we're going to return left, but why? Why do we have to return left? So for example, let's say our target was 4 here. If it was 4, then our middle would be here, right? Correct? Because 1, 2, 3, 4 subtracted by 1. So 3 divided by 2 is 1.5, floor it. So that will be 1. So here 3. So then left should be pointing as 1 and right should still be at 3. If it's here, then we wanna our mid is gonna be what? Our mid is gonna be this 5. 5 is greater than 4, so we're gonna move our right to mid subtracted by 1. So if we copy this, what did I do? If we copy this and paste it here, our left is gonna remain the same. Our y is gonna be mid, which is 2 subtracted by 1. So that's gonna be 2. Right? Oh, sorry. Yeah, 1. So now they're equal. Now what we're gonna do is we're gonna say, look, okay, so what is the number at? What is the mid at? Well, mid is left added by right. So 1 plus 1, 2 divided by 2 is 1. So 0, 1. We're gonna look at 1. And if 1, so this is less than, so current is less than target. So we're gonna move left middle is equal to, left is equal to middle plus 1. So what are we gonna say? We're gonna say target is 4, middle is 1, and then middle plus about 1, that is 2. And now that left is greater than right, we're gonna return 2 because 2 is where the index should be. So 0, 1, and 2, right here in the middle. That's where 4 should be. So that's the overview of this question. That's how you implement binary search in Rust. I hope this video makes sense to you guys. Thank you for watching and have a wonderful day.